Okay, number 1, consider the titration described above in the sample problems. I'm going to teach you how to do an ICF table to calculate the pH of the solution that's in the flask after you mix NaOH with HCl. Okay, so if we're combining NaOH with HCl, you know that this is a 1-to-1 ratio. So here's my balanced equation. And then for the NaOH, I've got 0.1 molar. So let me just do this over here. 0.1 molar, bless you, times 0.02495 liters of NaOH. And then I'm just figuring out what it is after it's diluted. We've got this volume of NaOH and this volume of HCl. So when you add those two together, you're going to get 49.95. So this is 0.04995 liters of solution. And then this comes out to be 0.0499. That can't be right. That can't be right. Somebody calculate that for me. That's clearly wrong. Right?
I got 0.499.
So the decimal's in the wrong place?
Yeah.
0.4999?
Yeah.
So can I just leave it like this?
Yeah. Yeah.
Okay. Yeah, the decimal's totally in the wrong place. Yeah. All right, and then I'm going to do the HCl down here. So this is going to be 0.1 times 0.025 divided by 0.04995. Now I'm doubting. When you add those two together, does it come out to be this?
Yeah.
Yeah, so that's fine. Okay. Can you do this for me and tell me what you get? Because on here it says 0.05. And I don't believe it.
I got 0.05.
You did?
Yeah.
0.05005?
No, I got 0.0501.
Okay, we're just going to leave it like this. Is that cool? Okay. All right, so there's that. And can I group this together and move it over? No. Can I? No? Okay. All right. Well, I need to move it over. Can I touch it and move it over?
Maybe if you click on the toolbar.
This?
Yeah. Sometimes it has like special things in it. Oh, I guess not.
Nope.
No.
Well, I didn't know.
Can I take a picture of this? Because I'm lazy? Is that possible? There's no point.
Oh.
Where did it
The
go?
whole thing. Oh, it's taking the picture.
No, let's just X that. Let's just forget it. It's fine. All right. Oops. Okay. How's that? Is that better? Yeah? Okay. Now, we don't care about the water. That column's not necessary. So we've got our NaOH. Where's my calculator? Yeah, what?
I might have messed you up on the NaOH one because I didn't multiply by 0.1 molar.
Oh, okay, so is the 0.049 right?
It's
Yeah.
0.05.
Okay.
Sorry.
That's fine, because I was about to question. Well, don't I need to know, is one of them, is this rounded?
No, that one's exactly 0.05.
This is the one,
I got it smaller.
Yeah.
you got the same thing?
I got 0.
The HCl is 0.0501. And the top one I got exactly.
The top one I got 0.0499. That's what I
Me
got.
too.
Yeah, I got the same thing.
Wait, but I got it.
That's because you didn't put a 5 feet.
Oh, my bad.
You're good.
Okay, so let's go back here.
Try it.
0.04995. Yes?
Yeah.
Okay, that makes more sense. All right, so this is 0.04995 and 0.05 and 0.
Never mind.
Okay, then this is same concentration. I'm going to run out of this. This is 0.04995 minus 0.04995, and this is plus 0.04995. So this is 0, pretty much. And then this is small. I've got 1 times 10 to the negative 4th. Double check me on that. See? Oh no. Yeah? Okay. Now, if we want the pH, so do you understand that we ran out of NaOH? Okay. So that's why I was subtracting that. Now, the pH is going to be the negative log of, well, if this is my acid, this is my final concentration of acid. I put it in here to get my pH. You should get a pH of 4. What? What's wrong? Oh, thank you. Okay, I did something wrong. Okay, we're good. That's it. Yes? Yeah. Moving on to weak acid, strong base curves.
Wait, I have a quick question.
Wait, what?
So, do you subtract the 0.04995 from the 0.05?
Yes.
Because when I did that, I got 5 times 10 to the negative 5.
You got 5?
Yeah, times 10 to the negative 5.
Yeah.
Well, I'm glad you're checking. So this, pH still the same, isn't it?
Yeah, that's such a small number.
Okay, so this is 5 times 10 to the negative 5, and this is 5 times 10 to the negative 5, and this is 4.3. Yeah?
Wait, how did you get this?
Huh? Calculator.
Why don't you do the same thing we did?
We're good?
Sure.
Can I go on?
It's fine, it's all the same.
Yeah?
Yeah.
Okay. Okay. Now we're on weak acid, strong base titration curves. Turn to the next page. Oh, hate it when I do that. Is it here? No?
No.
Here?
Yeah.
Okay. All right, so here you're going to notice that your pH is slightly higher, and that's because you've got a weak acid. Now, do you see how this is kind of staying constant a little bit? This is called the buffer region, and then the equivalence point is not going to be 7. The equivalence point you can see is actually higher. Okay, so a few things that you should note here is on the next page, they explain stage 2. So on the next page, I could make notes. Let me make a note here. Halfway to the equivalence point. The pH is equal to the pKa. You should absolutely memorize this. And one of the ions from your salt will hydrolyze, and that's what changes the pH. Do you want me to write that on here? So this is probably going to be at a pH of about 9. Did you say interesting?
I said in triangle PC.
Change. Long day. Yeah. Can I move on? Next page. Under stage 2. Wake up, Olive. Hi. Okay. Under stage 2, it says, from the beginning of the titration until the equivalence point is reached, the flask will contain a mixture of a weak acid and its conjugate base, and that means that most of the time, the reaction will qualify as a buffer solution. So that's why they have the buffer region labeled. Turn to the next page. Late night, Olive?
No, migraine.
Oh, I'm sorry.
Alright.
Okay. Exactly halfway to the equivalence point, half of the acid has been converted to its conjugate base. And then you've got the hydronium ion concentration equal to the Ka and the pH equal to the pKa. And then take a look at the next section. Can I go on?
Yeah.
The next section of the titration curve is where the pH is greater than the pKa. So this is beyond halfway and prior to the equivalence point. Look at the top of the next page. They give you all this information for the weak acid with a strong base. So prior to halfway to the equivalence point, they tell you pH is less than the pKa, halfway, pH equals it, beyond halfway, but before you hit the equivalence point, the pH is greater than the pKa, okay? And then stage 3, can I go on? The only thing you're gonna highlight here is this shaded region. The weak acid in the strong base produces a basic solution with a pH greater than 7 at the equivalence point because the anion, like I said, from the salt will hydrolyze to produce hydroxide ions, but the cation will not hydrolyze. Turn to the next page. Let's take a look at comparing titration curves. It's pretty obvious. If you were given something like this and asked to identify which one was for a strong acid or a weak acid, it's relatively obvious. Agreed, because of the pH of where you're initially starting, right? Okay, let's turn the page. Let's go to part 3. Over here. How much longer do we have after part 3? A little bit? Okay, let's stop.